Yeah, guys, I want to talk about a data type called div-t. Some of you might have seen it before, and okay, let me give you an example. This how it is. Um, it's something like this, div-t. So, yeah, division type. It's a structure type for uh, for integer division. Okay, so I want I would like to show you how I used it in an exercise. Okay, so but I know we could have different better ways to solve this exercise. Okay, but I just used it and it's worked quite well. So it's not necessarily going to be the best implementation, but I just want to share how I used it with you guys. So this exercise, paint calculator. So sometimes you have to round up to the next number rather than the standard rounding rules. Calculate gallons of paint needed to paint the ceiling of a room. Prompt for the length and width and assume 1 gallon covers 350 square feet. Display the number of gallons needed to paint the ceiling as a whole number. Okay, so if that's the case, if the if we have to round to the next whole number, uh, then I'll be assuming that even our length and width that will be taken as inputs should be uh, rounded to the next whole number. So this is what I did. Okay, all right. We have some constraints here. I said use a constant to hold the conversion rates. Ensure that you round up to the next whole number. Okay, all right. So remember, you can't buy a partial gallon of paint. You must round up to the next whole gallon. Yes, as I said. So we won't be able to say you need like 2.6 or 2.1 gallon of paint. If it is 2.1, then round it to the next whole number, 3. That's what exercise is saying we should do. I'm not the one saying it. It's the exercise that asks us to do that. So I'm going to try to solve this again. So okay, let's start. I say vi int calc.c says okay, oh, h um, okay, so we'll be prompted for length and width. Okay, so printf, okay, say length in feet, right, and get say length in width in feet. Okay, getting my inputs. I say to the inputs, and we have st. I just call size. I'll be using it to assign allocate the memory byte for the inputs. So inputs should be malloc size s list line and inputs. Let me say yeah, and s. Okay, and that inputs and okay, we need to declare variables here. Length and width Okay, so now I have to calculate the area. So I'll get an area here. Area should be the length times the width, and I think that way the number of gallon, right? Okay, so we said we are assuming 1 gallon covers 350 square feet. Display the number of gallons needed to paint the ceiling as a whole number. Okay, so for our calculation, let's first for our calculation it should be say 1 gallon is to 350. So how many gallons for, let's say for example, 600 square feet? So that'll be 600 divided by 350. All right, no problem. So it will be the area divided by 350 to get the number of gallons. All right, so let's keep the conversion rate, which is the 350 per square feet. So 16 integer, say what should we say, what should we call it, gallon per gallon per oh no, the area per gallon. Okay, so area per gallon should be 350. Okay, area per gallon is 350. So the let's say the number of gallon would be area divided by area per gallon. Okay, so let's say say we need cans to cover this area of ceiling. Okay, so number of gallon and area. Let's test this out. Oh, alright, alright. So there, okay. Okay, you need 1 gallon. You need 1 gallon of. Oh, that English is wrong. The English is wrong, but we'll correct it. Okay, so you need 1 gallon of. You need 1 gallon to cover 600. Oh, that's 600 feet. 600 square feet. So you need 1 gallon to cover 600 square feet of ceiling. All right, but this is wrong. Okay, because we know from our conversion that a gallon will cover 350 square feet. So if a gallon covers 350 square feet approximately, 1 gallon cannot cover 600 feet. It should be around 3, I guess. Let's try this. Say 600.0 divided by 350. Okay, so we should be looking at 2 gallons, 2 gallons of paint to cover 600 square feet approximately, because um 350 gallon and say 350 times 350, that's 700. So 3 by 3 is 700. So 2 gallons for 700, the same 2 gallon approximately for 600. So it's quite it makes sense. It makes sense. So now the main what I was talking what I thought from the beginning of the video I talked about the DFT. So this is where I use the DFT. Okay, because I'm dealing with integer division. I want to be able to round to not round. I'm not going to round per se, but I'm just going to. Okay, you get to see it. Okay, but the whole idea is this. I want to get first the ground division. Okay, the quotient of the division and the remainder of the division. So if the remainder is anything greater than 0, then the number of gallons should be the quotient plus 1, which is the next whole number. Okay, but if it is 0, it's just going to be the number of gallons we need will just be the quotient. Okay, let's put to work and see. So, and this functionality, the div type and its functions that you use are actually inside a standard lib header file. So I would start it from here. I'll say yeah. So right now we need the number of gallons not to be assigned yet. So to assign it, we first need to get this. So say C number of gallon calculation is equal to division of area by area per gallon. Area per gallon. Alright, so let's say so I used the if statement to get it done. Okay, so if mgc dot rem, the remainder, is greater than 0, then the number of gallon should be equal to n the mgc dot quotient. Okay, else the number of gallons should be equal to should be equal to plus 1. So the number of gallons oh no, number of gallons should be equal to the number of gallons should be equal to mgc dot quote plus 1 plus 1. Yeah, alright. Okay, so now we're saying the div T it's a structure type, so it has elements. It only has two elements, the rem and the quote. So the rem is just the remainder. So if the remainder of the deviation, if the remainder is greater than 0, so if it's anything greater than 0, 1, 2, anything, we approximate our number of gallons to the next whole number. So if let's say our division, the quotient is 2, and the division and the remainder is maybe 1, automatically we won't say the number of gallons will be 2. We say it's going to be 3, because that's what the exercise says. We should approximate to the next whole number. Alright, so I think this is it. So if it's not that we increment, we just increment the oh wait, if it's greater than 0, no, yeah, goodness, this is a mistake. I'm so sorry for this. So if the remainder is greater than 0, the quotient, the number of gallons should be equal to quotient plus 1. Okay, not this. I'm so sorry. Yeah, so if the remainder is greater than 0, we increment the quotient by 1, which is, we just say move to the next number, the nearest whole number. The next whole number, not the nearest, sorry. So else, should I say the nearest whole number or the next whole number? I don't really know. Like, man, it's been a long time I did math. I'm sorry. Number of gallons should be else the number going to be mgc.code. So if it is not greater than 0, which means it is 0, the number we're going to suggest be the quotient. Okay, so let's fix this typo here. I don't know how I'm going to do that. I don't want to implement any if statement for anything here, so I'm just going to do it that way. And okay, let's try this out. We say 20 by 30. Okay, it says we need 2 gallons. Oh, we need English. You need that gallons paints to cover this area square feet of ceiling. 20 and 30. Need 2 gallons of paint to cover 600 square feet of ceiling. So that is it, and that's how you just use div-t. I hope you find the div-t functionalities maybe useful. I don't know how much further I could use them, but I'm sure we could have more amazing use of them. And that's it for this video, and thanks so much for watching. I'll see you in the next one. Bye.